Hello all, this is Vivek Ramachandran from SquareX, and in this video, we will show you how browser-native ransomware works. So we open up with the victim machine view where we can see his Google Drive and a bunch of files in there, including a shared drive where there are other files as well. Now this is typical both for individual as well as enterprise users. And instead of the Google Drive, you could have had any online drive or storage or application data folders. Now let's see how the attacker can compromise the victim. So typically most people end up searching for things online. And here is an example where the victim is actually searching for a UML diagram creator. And the very first search result is a sponsored result supposedly from draw.io, which is a very well popular known application. So the victim believes that to be, the top result, and again, unaware that Google does not typically vet or in any way verify that this is the true draw.io. Once the user ends up clicking, he's taken to the attacker controlled application where he's requested for access to his storage to go ahead, store his UML diagrams, resources, etc. And once the user goes about authenticating and giving the requisite OAuth scopes, as you can see over here, which is the ability to edit, add, delete files from Google Drive, the attacker has full control. So we will see now, once the user goes about giving his consent, the attacker will redirect the user to the application. Now, given that most popular applications have open source clones available, it is fairly simple for an attacker to set this up where the deception continues. Alternately, at this point, the attacker, post receiving the OAuth scope grant, could just redirect the user to the real website where the user might have to log in once again. Now, at this point, the critical thing to understand is the attacker has access to the Google Drive. So let's go ahead, shift over to the victim machine, and we can see that the attacker is now deleting the files. We've made it a bit dramatic by adding a bit of delay between the deletions so that we can visually show you. And whichever shared files that the user has ability to delete, the attacker deletes those as well. And of course, he can also empty trash. Now, post this, the attacker leaves a ransomware note on the Google's drive, on the user's drive. And this is very similar to what we are accustomed in the endpoint world. And we can see that at this point, this is a typical ransomware note requesting for money to be sent via crypto. So as you can see, this is almost identical to what used to happen on the endpoint, but now this attack is living and completely breathing within the browser. So on the endpoint, ransomware would have infected, but of course you had an EDR, anti-ransomware, which may or may not have picked it up. Post that, the attacker would have gone ahead, encrypted, deleted files, and left a ransom note. Now, in the browser-native ransomware world, what is happening is pretty much identical, but we now translate everything to the browser cloud world. So here the attacker ended up getting access to online storage via chaining a malvertising and an OAuth consent grant attack. Post that, he went ahead, removed all the files, put a ransomware note in. Now let's move over to the attacker view to see how it would have looked like for him. Once he received the OAuth scope grant from the user, he can literally go about creating a replica at his end using various softwares available. And we can see at this point in time, he's remotely selecting and removing all collaborators. Once this is done, he goes ahead at this point in time and downloads the entire user files as a zip file. So he can keep a copy and probably send it back if the ransom is paid. Now post this, just like we saw from the victim view, he goes ahead, deletes all the files. And once all the files are deleted, he goes ahead, uploads his ransom note. So you can see how easy it is for the attacker to orchestrate all of this remotely. Now, with a big difference, at this point, EDRs have zero visibility of what is really happening in the browser or on cloud storage. B, your cloud storage security probably allows this through at this point in time simply because the user has granted OAuth scopes, and this is pretty normal for most applications to take and do. And finally, as we can see, the ransom note was left back. So in summary, this is an example of what SquareX has uncovered browser native ransomware to be capable of doing. That's all for this video. Thank you.